Okay, part two, pointers. We are continuing with part two, dynamic memory. Okay, what we talked about was so far we had talked about creating pointers and assigning existing addresses to pointers, if you remember. So if you go back and look at part one, that's what we did. We created a pointer, we created an int variable, and we made the pointer point to the int variable. So now we're going to talk about what is the point of this pointer. So here's a recap of what we did last time. Int star ptr, pointer to an int num is a regular integer, value of 100. Then we take ptr and make it point to num. And then we output num through num and ptr, right? What's the point? We already have num. Why create a pointer? So the idea of these pointers, this, if you notice, is done during compile time. It's not done during runtime. So you write the code, you compile it, and then you run it. The pointer gets created, the memory gets allocated. And when you leave the program, when you quit the program, then memory gets released. The idea of the pointers is to be able to allocate memory during runtime and release it as your program runs. Most of the programs that run out there in the real world situation, like in simulations, don't just run and quit. They run for days and days and days because they are trying to constantly analyze data and do something with it. So when they're doing something like that, when the program is constantly running, you don't want to hold the memory that you're using for some of the variables. So you allocate memory, you deallocate memory as and when you don't need it. And that is happening during runtime. And that cannot be done with these automatic variables that you're creating. So we need to be able to create variables during runtime, allocate memory for them during runtime, and deallocate memory when we are done with them. This is the purpose of using the pointers, the new and the delete keywords. And the new operator allocates memory at runtime. So then what we do is in star ptr, we create a pointer and we say ptr equals new int. While the program is running, it allocates memory for an integer. Star ptr equals 10. We put a value into that integer that we just created on this line, and star ptr equals 10, cout star ptr. So now notice the middleman of that num doesn't exist here. The only way to access this value or this new memory that was allocated is through the star ptr. There's no more num associated with this or x or whatever. You only have ptr, and you allocate memory through ptr, saying ptr equals new int. Notice the syntax. This is all syntax that you just must memorize. Star ptr equals 10 says put a value in the thing that is pointing to and output it. Okay, so if you look at pictures, it looks like this. Int star ptr equals null ptr. Declare a pointer. Its address is 2000. It's holding an address that is null, not pointing to anything. Okay, ptr equals new int allocates a memory. So now you have a memory with an address of 1200. That 1200 goes in here, and this has nothing in it. That's junk in it. It's not initialized, right? That's what has happened now. Then you say star ptr equals 53, puts a value of 53 in this because that's what we just did. So int star ptr equals null ptr initially creates a null ptr with nothing in it. Ptr equals new int allocates this memory, takes its address, put it into ptr, and then we put a value into it using star ptr. Now the only way to access this ptr, this value of 1200, this memory location 1200 with the value 53 is through the ptr. There's no other way to access this memory location that you've created. So now how do we release it to the operating system? So the delete operator deallocates the memory. So once you create the PTR, allocate memory using the new keyword, put something in it, output it, then you delete it. When you delete it, it simply releases the memory. It's really not deleting any memory, right? The memory cannot be deleted, but it can be released back to the operating system. So that looks like this. PTR, null PTR. Declare a PTR pointing to nothing, has an address of its own, allocate memory for it. 1200 goes in here saying I'm pointing to this new memory that we just allocated. Put a value in it, star ptr equals 53. Delete it. So this link is broken. Notice that link is no longer there. This memory is now free to be used by other applications in your operating system. That is what it means to allocate memory and deallocate memory. Remember, there's nothing like deleting from your memory. You can't delete memory, right? You have 4 gigs of RAM, 16 gigs of RAM. The RAM is still there. You're not deleting it, but you're releasing the memory to somebody else. So maybe your Word or your Google Classroom or whoever can access it. Okay, so the new and delete keywords. That's what we're learning. And then we set PTR equals null PTR. Very important. Once this memory is released and this is not pointing to anything, set it to null. Good habits. Okay, so let's look at code dynamic ptrs.cpp. So I already have code written here. Let's take a look at this. Okay, dynamic. So, no, this is not it. Dynamic PTRs. Let me see here. Yeah, so there's a difference between, we haven't seen arrays yet. Dynamic ptrs.cpp. So this is just creating dynamic PTRs, meaning one integer, right? In star PTR equals null. It's a bad idea to do anything before allocating memory. Always allocate memory. If PTR, bad PTR value, and if you try to do this, that will output a bad PTR. You don't know what it's pointing to, so never do that. Allocate memory, put a value in it. So if PTR says PTR is not equal to null, right? If it is pointing to something, well, it shouldn't be because right now I initialized it to null. But in case you forgot to initialize it, if it's pointing to something, then it's going to say bad PTR value. I'm pointing to something bad. It's not good. That's just to show you. PTR equals new int, allocates memory, put a value in it, output it. Again, delete it. Do not allocate new memory without deleting it because then you're leaving the other memory hanging. Delete it, set it to null, then allocate new memory to it, and then set a value to it and print it. Okay, so when you run this, I'll show you how all the errors that you can get. So g plus dynamic PTRs / dynamic PTRs. Help if I spelled it correctly. Okay, there it goes. That's the value, right? PTR's value, new PTR value. Now, here are some mistakes you can make. Let's say I forgot to allocate. Well, first of all, let's start with this. If you forget to initialize it, it may be pointing to something bad. Okay. Okay, hang on. Let me move this aside and create a duplicate session so we can see it on both screens so we're not going back and forth. Okay. CD. The asterisks here. Okay. Dynamic. Okay, let's just open dynamic ptrs.cpp here and close it out of here. Okay, I took out the null. Now we come here and we build it and you run it and it tells you PTR is used uninitialized in this function. So it knows we're going to get an error message. And so bad PTR value is that. PTR's value is 15, just so happens from the previous time, right? Well, we did a new int, but that's bad PTR. See, that number shouldn't be there. And it may not be consistent all the time. At some point in time, it'll crash when you do a star PTR with that. So it's always good to do this. Okay. And you come here, and if I forget to do this, for example, if I forget to allocate memory, okay, forget to allocate memory, and if you compile it like that and you try to run it, you get a segmentation fault because I didn't allocate memory. PTR equals new int. Without allocating memory, I'm trying to put something in there. So anytime you start getting segmentation faults, you know that your pointer is bad. So don't do that. Likewise here, without deleting and setting to null, if you allocate new memory, what's happening is if we go back to our slideshow and take a look at it, here is our slideshow, and if we go here, when this is pointing to this, if you don't deallocate this, and if you take this and say PTR equals new int, what you're doing is you're taking this and you're making it point to something else. When you do that, this memory is hanging if you haven't deleted it. Now, there's no other way to access this memory, but it's tied up by your pointer because you didn't delete it. So this delete is very important. If you don't delete it and if you move this thing away, then you have a memory leak. That's called a memory leak because now your memory is getting leaked and there's no other way to, to put a plug on it. The only way to do that would be to use this PTR and delete it. So don't take away this by doing this. Don't make PTR equals new int without deleting it. So deleting it is very critical. So again, it depends. Sometimes you will get a segmentation fault, sometimes you won't. Now you don't, but eventually you will get a segmentation fault because you will have so much memory leak that all your memory will have leaked away, and 4 gigs of memory has leaked away because you put it in a loop or something where you're constantly not deallocating the memory and you're allocating new memory, then you're going to have a crash because your program, there's no more memory left. Okay, so things to think about. Okay, so those are dynamic pointers. Those are dynamic pointers to single integers, right? Now let's talk about arrays. That's where we're really headed with this, arrays. So allocating memory for an array. Int n equals 5. Int pointer list equals new int n, which is 5 elements in my dynamic array. So I just allocated memory dynamically during runtime. So list is the name of my array. It has an address and it points to 5 elements, an array of integers, and the name of the array always points to the first element. And then we step through it. Okay, so each one of them has an address. Notice the first address is what goes in here. Then as the pointer moves, the address changes. So int n equals 5, int star list equals null PTR, then say list equals new int of n. This is another way to do it if you didn't initialize it right away. See the difference between the two? Here you create it and automatically initialize it. Here you create it, set it to null PTR. So the difference, don't put an asterisk here, that will be wrong. Okay, accessing the array works exactly the same way. Nothing changes. Once the array is created, think of it like a regular array. For I equals 0, I less than n, I plus plus, list of I, output list of I. Nothing changes for the most part. You have to delete it. Delete square bracket array PTR. Remember, it's an array. So the syntax is different. Again, pay attention to the syntax as you go through these things. Things to watch out for. Always things to watch out for when you are working with pointers. Int n equals 5, int star list 1 equals new int n, right? This is 5. Fine, you're creating a pointer and allocating memory. List 1 points to this array of 5 elements. Of course, I put some values in here. We haven't put any values in the code there. But here is the problem. Int star list 2 equals list 1. You're creating another pointer and making it point to list 1. Okay, just fine too. So now list 2 and list 1 are pointing to the same thing. That's what this says. It's a reference. Delete list 1. The minute you delete list 1, this memory has been freed, which means list 2 can't access it either. The memory is gone. It's been freed. That means neither one of them are connected to this. That's something to watch out for. Okay, so don't try to access list 2 after it's been deleted by list 1. If you really wanted 2 different arrays, here's how you need to do it. Int star list 1 equals new int creates this array with these elements. I don't put them in there, but they're there. Int star list 2 equals new int n. Create a list and allocate memory for it. This is allocating memory for it. We didn't do that in the previous step. Then you go through a for loop and copy one element into the other. Very important. It's called a deep copy. You're allocating memory for list 2. Now you can delete list 1, doesn't matter. List 2 still exists. They're independent of each other. Okay, so things to keep track of. Let's look at arrays PTR, array PTRs.cpp. Here's the next sample code. AI array PTRs.cpp. Okay, this is again similar. We are now creating arrays using these dynamic pointers. So int star PTR equals null. Here's a regular array. This first shows you how to do it with the regular arrays. Then we do pointers with dynamic arrays. So pointer is there, a regular array is there, list of cap. Int my list of cap is another array with all elements set to 0. PTR equals list. So what I do is I take the first address of list and put it to PTR. So now PTR is pointing to list as well. List of 0 equals 5, list of 2 equals 10. But PTR is also pointing to the same array. I can print using PTR. Cout star PTR will print 5. And I can do pointer arithmetic. What does that mean? PTR plus equals 2 says move the address. PTR, remember, is a pointer. It has the address. Move the pointer over 2. Then cout star PTR prints the third element. Because we are in 0, if you add 2, we go to 2. 0, 1, 2, we skip 1. That's all it is. Enter 5 numbers. We read using PTR. This is a little tricky. PTR equals list. List is the name of the array which holds the first address. PTR is a pointer which requires an address. You make it point to the first element of the array, the address of the first element. PTR less than list plus 5. We know capacity is set to 100, but we have 5 elements in the list, probably because we are reading 5 numbers. So list plus 5 says don't go beyond fifth address starting from the first address. That's what we're saying because we only want 5 numbers. So this will limit it to the first 5 elements in the list. PTR plus plus, anytime you add plus plus to PTR, it moves to the next address. It doesn't move to the next number. Okay, so that's just what is called pointer arithmetic. It knows to move to the next address. See in star PTR, we read from the user. We again follow the same for loop and output to the user. Now, do you have to do this? No, this is for your understanding. You can just use a regular for loop. For I equals 0, I less than 5, I plus plus is what you would do. Okay, and that's what we use for the most part. But this is just, take a look at it. This is interesting code just so you know how to use pointer arithmetic and how it works. Okay, we won't use much of this in your code, but it's for your own understanding. Okay, that's array PTRs. Then we will talk about, and here I wanted to also show you about dynamic PTRs. That's the other code, dynamic arrays. Dynamic arrays.cpp, I believe that's what I called it. Okay, so this is purely dynamic arrays. Notice in star PTR equals null, temp PTR equals null, and then we have a cap equals 100. PTR equals new int square bracket cap. This is create a new array with a capacity of 100 and make my pointer point to it. So now we are actually allocating memory for the array during runtime. And then we read 5 values into it. Notice I just use a regular I as a subscript. I equals 0, I less than 5, I plus plus, C in PTRI. Then I output them again. I can use temp PTR like we did before, or you can simply use your I. If this is confusing, just use I. I equals 0, I less than 5, I plus plus, C out, PTR square bracket I. Okay, that will work as well. Delete star PTR. Do not try to delete temp PTR because there's only one array and that one array has been deleted by PTR. So don't delete PTR, temp PTR again because temp PTR is not pointing to anything. It's just a temporary PTR. Set them both to null, that's okay. But delete it only through one PTR. Okay? Again, just information. We are going to use dynamic arrays, but not quite like this. Okay? Okay, now let's talk about pointers to objects. This is your homework number 2. Okay, be able to create pointers to objects and pointers in objects. So this is a class point. This class, you know, nothing has changed in the class. We have a constructor and a print function. We have 2 private data members. And here is the constructor, sets both x and y to 0. And the print function simply prints it. I don't show the print function here, but it just prints the point. Now here is in main, instead of creating a regular point, I'm creating a pointer to the point. Point stars, just like int star creates point star equals new point. New is the keyword. After that, everything is the same. You sample.print will print it. So once you've created the object, everything works the same way. Okay. Okay, so here is the code for that. Point is a constructor with parameters. Print function, constructor with parameters has been implemented. Print function simply outputs it. And point is 0.1. So there's actually a little bit of an error here. This should be printing it. You have to dereference it because it's a pointer. So you have to do this, otherwise it's not going to print. Okay, because you sample is a pointer, you have to dereference it to get the value and then print it, which is what this shows here if you look at it. 0.1 and 0.2 are pointers. New point calls a default constructor. New point 89 calls a constructor with parameters. Star 0.1 dot print, the parentheses is a must. Star 0.2 dot print prints it. Okay, so instead of the parenthesis, can I do this a little different? I can do sample like that. Okay, that is the same as this whole thing. So people forget to put the parenthesis. So we have a new operator. This is called a pointer operator. So instead of doing this whole thing with the asterisk and sample dot, you can simply do sample pointer, saying sample is a pointer. So you automatically take it and do this because I will forget to do it. So you can do one or the other. So that's what this is saying. Member access operator allows access to objects members with the syntax a pointer b instead of this. Okay, so instead of doing it this way, you can do it this way. And a delete operator and objects work exactly the same way. You would do delete an object. Okay, so here's code. Let me take a look. Let's take a look at the video code. Okay, part 1. This is just trying to. This is for your homework 1. This is where your homework 1 starts. Okay, so cd video cd